Today I'm going to talk to you about one of the most important concepts in photography. It's called depth of field. Depth of field is how much of the photograph is in focus. So on the left-hand side, you can see that the girl is in focus, but the background, the wheat field or the grass, is blurry, and that's called small or shallow depth of field. On the right-hand side, you can see almost all of the photograph is in focus, from the rocks right in where the photographer is standing, right close to the photographer, and then into the far distance. That bridge stays pretty darn in focus, and that is called large depth of field. Here's another example of small depth of field. It's small, or considered shallow depth of field, because only a tiny portion of the photograph is in focus, the Paris lock, and all the other locks around it are fairly blurry. Here are a couple other examples of shallow or small depth of field. Here you can see the camera is focused on the spider web and the little dewdrops on the spider web, and you can see that there's just a small portion, that center portion of the photo is in focus and the rest is blurry. And on the right, the tip of the violin is in focus, but the violin player or the craftsman is blurry. And so these are shallow or small depth of field, and you can control this. On the left, shallow depth of field, because the foreground is in focus and the background is blurry. On the right, large depth of field, because everything in the Eiffel Tower is in focus. So the depth of field is the measure of how much of the image will be in focus. There are three things that control the depth of field: the aperture, the focal length of the lens, and how close you are to the subject. So what's aperture? Aperture is the opening in the lens. You can see on this diagram on the left-hand side, notice that the camera lens, that aperture, which is the hole in the lens, is quite large. You can see the light shining through here. And as we move to the right, that aperture gets smaller. Now that aperture is measured and called f-stops. And that's why you see these here, f2.8, f4, f5.6, and so on. The smaller the f-stop number, the smaller the depth of field. The larger the f-stop number, f22, which is the largest f-stop number here in this diagram, the larger the depth of field, the more is in focus. Now, what's a little bit confusing about that is you can see the small f-stop number actually corresponds to the largest aperture. So there's sort of an inverse relationship, which is a little confusing. But if you remember, small f-stop number, small depth of field, larger f-stop number, larger depth of field. That's how you can remember it. And you can control this setting on the camera, and we'll talk about that. So here's an example. This photo on the left-hand side you can see is taken at f5.6. This is what it looks like in the aperture. And it's a smaller number than f36 over on the right-hand side. And because it's a smaller f-stop number, we have a smaller depth of field. The larger f-stop number, f36, gives us a larger depth of field. And everything else about these two photographs were the same, just changing the aperture or the f-stop. Now the aperture and the f-stop, remember, they're kind of referred to, and they're kind of the same thing. The f-stop is the measurement of the aperture. So photographers kind of sometimes talk about aperture and sometimes talk about f-stop, but they're referring to the same thing basically. So here's a photograph that has a very shallow or very small depth of field, right? And look, it has a small f-stop number, f2. Let's see what it looks like with a larger f-stop number. Here's f16, the exact same photo, changing the f-stop, and you can see still fairly shallow. I mean, the grass is somewhat blurry, but it is definitely a larger depth of field. Here's another example. Here's f2.8. So see how some of the seaweed is in focus, but not all of it, just a little. And here is the larger f-stop number, f22, which is a smaller aperture, as it says. And there's much more of the photo in focus. Here's another example. One of the problems, though, of using a small aperture, tiny hole is it doesn't allow as much light to get through. So sometimes the camera has to compensate by increasing the shutter speed in terms of the time that the aperture is open to the sensor. So sometimes you get problems where you can see on the right hand side the whatever this is some sort of whatever seaweed or something. You can see that it has some motion blur because probably the wind was blowing it around as the camera was taking the picture. So there are trade-offs. That's the point here. The right hand image was taken at a slower shutter speed to get the correct exposure. Because of this, the fishnet, that's what it is, has become blurred, a little bit of a motion blur. So if you look at these, where was the camera focused on? If you look carefully, you can see both photographs were focused on the post closest to the photographer. But which image was made with a small aperture and which with a large aperture? Now don't get confused between aperture and f-stop, right? So the smaller aperture is a larger f-stop. So it would be the one on the left. But again, let's not confuse things. Let's just say that the f-stop, larger f-stop over here, larger depth of field, small f-stop to the right is the smaller depth of field. Okay, the second thing that controls the depth of field is the focal length of the lens. And that's actually like how big the lens is. On the left-hand side, you can see it's literally smaller. So a short focal length will have larger depth of field, allow you to get more depth of field. The longer focal length, these nice big zoom lenses, give you shallower depth of field. And we'll experiment with this in class so you can get a sense of that. And that's why on your camera phone, your camera lens is tiny, right? And that gives you incredible large depth of field. Have you noticed your camera very rarely has the background blurry unless you're on like portrait mode or something? And that's because the focal length is so small that it's almost impossible to get a shallow depth of field naturally on your phone. So here, look at these two photographs. They were taken exactly the same except different focal lengths. So the one on the top was taken with a smaller focal length, 24 millimeters, which is like a wide angle lens. And the one on the bottom, same photo, except it was taken with 100 millimeter, which is a telephoto lens, like a zooming lens. So you can actually control the depth of field partially by zooming in and out using your lens on the camera. So the more you zoom out, increase that zoom, you'll get a shallower depth of field. And then the third variable is distance to the subject to the camera, like physically how close you are to the object. So these three photographs are exactly the same, except that the person, the photographer, was just getting closer and closer to the car. So from far away, you can see lots are in focus, getting closer. You can see that background is getting a little blurrier. And then when you're really, really close to that car, it's very blurry background. So if you want to have a shallow depth of field, get close to that object or your subject. So in summary, depth of field is affected by three factors: the aperture, the f-stop, the focal length of the lens, like the zoom lens, the type of lens, and the distance from the camera to the subject. Okay? So I know that this is somewhat confusing, and it's one of those things that you actually just have to experience to really get it. So we are going to practice this in class together. So don't worry if you're a little bit confused at the moment. This is going to be your assignment, and I'm going to help you with it. Mrs. Smith will help you with it if she's your teacher. So I want you to take about half large depth of field and half small depth of field for this assignment. It can be anything you want. But at the end of this assignment, I want you to be able to control the depth of field. Like if you have a vision, I want to take a photograph of my friend with a shallow depth of field so that the background is not distracting, then you'll know how to do that. That's the goal. So take a variety of photos with a variety of different depths of fields. You'll evaluate your photos carefully, look through them carefully, and I'd be happy to consult with you. Mrs. Smith would be happy to consult with you. Choose ones with the strongest composition and the most interesting photographs, but that also clearly meet the project criteria. Please do edit them in Photoshop, crop them, adjust them, make them look their best. And this time you're going to turn in 2 photographs. One, your best large depth of field where everything's in focus, and your best small or shallow depth of field where there's just selective focus, single, like a blurry foreground or background. And you'll turn that into Google Classroom. All right, so don't be intimidated by this. It's very common the first time you're introduced to this depth of field concept to be a little bit confused, but it will become clearer as you practice. Good luck.